Dear students, Assalamu alaikum wa rahmatullahi wa barakatuh. Today I will give you a brief introduction about conic sections, and later on we will start. Without wasting more time, we will start the syllabus. Conic sections, as the name suggests, or in simple words, we can say that conic sections are the sections of a cone. Sections of a cone. How these sections are formed? Suppose, first of all, we will learn how a cone gets formed. Let L be a fixed line and M be a rotating line which rotates at a fixed point, say V, about this fixed line L. So when this line rotates about this line L, then at some time it will reach here. Its position will be this. So the path traced by this line M, it will be just like this. It will be just like this. You can see practically by tying at the middle two pens. Rotate one pen about at a fixed point about other pen and keep one pen fixed, and you will see that it will trace a path like this. And so from this we get a double napped cone. This is known as a double napped cone. This is known as the upper nape, this one, and this is the lower nape. Now if we take a plane and intersect this cone with the help of this plane, we get different types of shapes. First we will keep this angle, say this angle is alpha, and we will intersect. Let's take this is a plane, and we will intersect this plane first. Suppose this plane, the angle formed between this plane and the fixed line L be beta. Now if this beta is equal to 90, that means it will be perpendicular. This plane will cut this cone perpendicularly like this. That means this angle is 90. So it will cut it like this, and it will form a, we get a circle. When this plane cuts perpendicularly this cone, we will get that time we get a circle. So when we take this alpha, case second, when we take alpha less than beta less than 90, then this plane will cut it like this. If we alter, it will cut it like this, and we get an ellipse. And if we alter this, again, if we alter this beta again, that means we take beta like this, 0 less or equal to beta less than alpha. Now we take beta less than alpha. That means it will cut it like this, like this. Our plane will be like this. So we will get a figure like this, U-shaped figure, and that is known as a parabola. Again, if we take, sorry, in this case, if we take this, when beta is equal to alpha, here when beta is equal to alpha, at that time we get parabola, this U-shaped figure. And if when case fourth, this is third case and this is fourth case, in this case it cuts both the naps, both the naps, and at that time we get hyperbola. At that time we get hyperbola. So in first case we get circle, second case, in this case when alpha is less than beta we get an ellipse, in third case when beta is equal to alpha we get a parabola, and in fourth case we get a hyperbola. At that time this plane will cut also this and we get a shape like this. In both the naps we get two shapes, U type shapes, and that is known as a hyperbola. Now what is the definition of a parabola? Parabola, it is the simply, it is the locus of a point. Locus means path. It is a path traced by a point. But this point traces a path in such a way that it is equidistant. It is equidistant from a, वो नीचे है रिसीवर के ऊपर, such that it is equidistant from a fixed point, this, and from a fixed straight line, this. The fixed point, this fixed point, it is denoted by F and is called the focus. And is called the focus. And this is called, this fixed line is called the directrix. Now, if a line passing through the focus and perpendicular to this directrix, it is known as the axis. This is the axis of the parabola. Suppose we have DM as the directrix and F as the focus. And this is the definition. That means this. If PN, PF, so by the definition of the parabola, this point always remains equidistant. So this path formed by this point is known as a parabola. Is known as a parabola. So P by definition of a parabola, this Pn is equal to Pf, because it is the locus of a point which moves so that it is equidistant from a fixed point, this that is focus, and from a fixed straight line, that means from directrix. So without wasting more time, we'll go to the standard equation of parabola. Standard equation of parabola. It often comes in your question paper. Now we take F as the focus. Let F be the focus. Say, and DM be the directrix. and we draw FZ perpendicular DM, and suppose this A where this FZ cuts the parabola, we take this A as midpoint of FZ, midpoint of FZ, and let this FZ is equal to 2A, which implies, since A is the midpoint, which implies AZ is equal to FZ, sorry, AZ is equal to AF is equal to A. Now, if we take this A as the origin, if we take A as the origin, that means this will act as, this line will act as y-axis. So here, this AZ, it will be equal to minus A. It will be equal to minus A. By taking A as the origin, by taking A as the origin, we will have this AZ. When we take A as the origin, then this AZ will be is equal to minus A, because taking A as the origin, since AZ is equal to A, so but it is on the left side of the origin, so it will be minus A. If we take AZ is equal to X, or because it lies on X-axis, we have chosen A as the origin. Now this is the y-axis, this is the x-axis, as this AZ or this minus A lies on x-axis, so x is equal to minus A, or x plus A is equal to 0 is the equation of the directrix. Equation of the directrix. This is the equation of the directrix. Sometimes short answer type question may come. Find the equation of the directrix of a parabola, and this is the directrix. Its equation is x plus A. But when the parabola is symmetrical about the positive, it is symmetrical about the positive x-axis, and it opens along right side. Later on we will see the symmetry of this parabola. Now we will use the definition. We will use the definition. Suppose point pxy lies on the parabola. Pxy lies on the parabola. By definition, we have this pf is equal to pn. Pf is equal to pn. Now, since A, we have chosen that A is the origin, so accordingly, coordinates of F will be A comma 0, because on x-axis y coordinate is 0, so coordinates of F will be FA 0, and similarly coordinates of n will be, it will be minus A comma y, because Pn, this Pn is perpendicular. Pn is perpendicular on what? This directrix. So this Pn, this minus A Pn, this Zn will be y, because Px as, because Pf P we will have coordinates of what? This n will be minus A comma y minus a comma y, because this is Zn. Coordinates of P are x comma y coordinate of P is y, as Pn is perpendicular on directrix, so y coordinate of this dm, y coordinate of m will be y. Now by distance formula, Pf will be under root x minus a whole square plus y minus 0 whole square is equal to Pn. It will be under root x plus a, because here it is minus a, so it will be plus a whole square plus it is y minus y whole square, or on squaring both sides and simplifying this, we will get y square is equal to x square plus a square plus 2ax minus x square minus a square plus 2ax. First we will square, and then here it will be 0. Transferring this side to this side, we will get y square is equal to this. That means y square x square will get cancelled, and a square. This is 2ax. It will be y square is equal to 4ax. That is the required standard equation of the parabola. Simple. It is simple. By using the definition, first we will get the coordinates of f and coordinates of this n, and by definition we use the definition of parabola, and by using this distance formula we will get the standard equation of the parabola. And here this a is greater than 0. A is greater than 0. That is the focal distance. This distance of the focus from this point A. This A is sometimes called the vertex of the parabola. Vertex of the parabola. Let us move on. Now we have derived the standard equation, that is y square is equal to 4ax, where a is greater than 0. Similarly, we can derive the other equations, that is y square is equal to minus 4ax, and this parabola will be like this. It will be like this. This is the directrix. This will be point A. It will open to the left. X square is equal to 4ay. It will be symmetrical about the positive. It will be symmetrical about positive y-axis. Here, this is the directrix. This you will. बेटा जाओ, डिस्टर्ब मत करो. X square is equal to, sorry for disturbing, x square is equal to 4ay. This parabola will open upwards. And lastly, x square is equal to minus 4ay. You may have understood that this will open downwards. This will be its directrix. So we see that if if in the standard equation, if in the standard equation of the parabola, it will have y square term. That means it will on it will open on what? It will open on this x-axis, x-axis. And if a is greater than 0, then it will open towards right side. And if a will be see, if it contains y square term, then it will open on this x-axis, and if it contain x square term, it will open on this y axis. If the right side is positive, then it will open on positive this positive side of x-axis, and if it contains negative term y square like this, y square is equal to minus 4x, then it will open on negative side, that means left side of this x-axis, left side of x-axis. Now sometimes you may be asked about general equation of parabola. General equation of parabola. It is simply, suppose we will take this directrix. This is the directrix. This is the parabola. We will take equation of directrix as ax square plus bx plus c, or it is quadratic equation. It is ax plus by plus by plus c will be the straight line. So let's take this as the equation of the directrix, and this f a comma b be the coordinates of this focus, be the coordinates of the focus. Suppose as we have done earlier, p point p x y be the any point on this. So we will likewise use this pf is equal to pn. Pf is equal to pn, and this what will be pf? It will be under root x minus a whole square plus y minus b whole square is equal to pn. Distance from a straight line, distance of a straight line from a point, it will be simply distance of a straight line from a point. It is, sometimes we write the modulus, or it is ax plus by plus divided by under root coefficient of x square, that is a square, plus coefficient of y square, that is b square. Coefficient of x square plus b square. On squaring both sides, you will get x minus a whole square plus y minus b whole square is equal to ax plus by plus c whole square divided by a square plus, solving this or transfer the like terms on one side, you will get an equation, and that will be the general equation of the parabola. Now let's see the equation. Let us see the exercise second on page this page 9. Find the equation to the parabola with focus. Now instead of fa0, it is given this fab is given, and the directrix likewise ax plus by plus c it is given. So you will get, sometimes here we take the modulus of this, and if we take this question 1, by definition, we have focus here. Focus is given as f 3 minus 4, and directrix is 6x minus 7y plus 5 is equal to 0. Now, by definition of a parabola, if f is the focus, we have let if pxy is be any point like this, pxy is any point on this parabola, then we have pf is equal to pn. Pf is equal to pn, which implies by distance formula x minus 3 whole square, because instead of a it is 3 plus y plus 4 whole square is equal to, it is modulus of 6x minus 7y plus 5 divided by under root of this 6 square plus minus 7 square, coefficient of x square plus this. And by solving this equation, we will get the required equation. By solving this, you will get the required equation of the parabola. Likewise, we have to square both sides, and then by cross multiplying, we will get the required equation. Question number 2 here. You will see question 2. Focus. Here focus, it is FAB, and directrix equation, it is this. Simply, as we have done question first, equation of the directrix is this, and coefficient of x here, instead of 6 it is 1 by a, instead of 7 minus 7 it is 1 by b. Likewise, question 3 and question 4. Now we will go to question number 5. Find the orientation. Find the orientation length of the lattice rectum. Question number this says find the orientation length of the lattice rectum, coordinates of the focus, and the coordinates of the ends of the lattice rectum of the parabola. First, I will define what lattice rectum means. Lattice rectum. Lattice rectum, it is the line segment. Suppose we have the parabola and f is the focus. The line segment which touches the parabola at 2 points and passes through the focus, which passes through the focus and touches the parabola at 2 points, is called the lattice rectum of a parabola, and in general we denote it as LL dash. LL dash. Now we have this, if we join this say Ln. Now by definition of the parabola, Ln is equal to Lf. We know that we have taken Ln is equal to 2a. That means Lf is equal to, so Lf is again 2a. And similarly L dash f is equal to 2a. So length of this lattice rectum LL dash is equal to LF plus L dash F is equal to 2a plus 2a, it is 4a. This will be the length of the lattice rectum, that is 4a. Now let us come to our question, that is find the orientation length of the lattice rectum, the coordinates of the focus, and the coordinates of the uh, this coordinates of the lattice rectum. What will be the coordinates of the lattice rectum? What will be the coordinates of lattice rectum? Coordinates of the lattice rectum will be here. This is the origin. So if we have focus say AB, focus is AB, or you can take it as A0 if this is the origin. So here it is A, and coordinates of this will be A, A, and so this distance will be again A. This distance will be again A. As this is A, so it will be plus 2A. That means this is 2A. This distance is 2A, so its coordinates will be A plus 2A, and coordinates of L dash will be A comma minus 2A. So we can say that the coordinates of LL dash will be A comma plus minus 2A. A comma plus minus 2A. Now we have question 5. Question 5 is find the orientation of y square is equal to 4ax. Orientation means it will be symmetrical. It will be symmetrical along, because it contains which term? Y square term. So it will open along right side, and it will be symmetrical about this positive x-axis, because it contains y square. That is about the orientation. Coordinates of the focus, coordinates of the focus are f a0, fa0, as we have seen earlier in this coordinate, and this length of the lattice rectum, it will be ll dash, it will be 4a, and coordinates of this lattice rectum will be, as we have seen, that a plus a comma plus minus 2a. Now let's take another question, that is the question is not seen. Question 6. Question, I think it is x square is equal to, and this is y square is equal to, perhaps it is 4x. This is y square is equal to, here it is 8. It may be 8 or something. Here it is x. It is 4ay. Now question 6. Question 6 is x square is equal to 4ay. X square is equal to 4ay, where a is positive. Can you say that what will be its orientation? As I told you earlier that it contains what? Square term, and here on RHS it is positive, so it will open upwards. It will be symmetrical about y-axis, or you can say that positive y-axis. positive y-axis, and likewise you can see the other items, that is coordinates of the focus and ends of the lattice rectum. Now here question, another question, find the value of p when the parabola y square is equal to 4px goes through the point 3 minus 2. Question 11, find the value of p when the parabola y square is equal to 4px goes through point 3 minus 2. We have equation of parabola is y square is equal to 4px. I am going fast. You may understand that way I am going fast. Y square is equal to 4px, and since it passes through 3 minus 2, 3 minus 2, that means this is the value of x and it will be the value of y. Substitute in this equation, you will get the required value of p, that is it is minus 2 square is equal to 4p into 3, which implies p will be equal to 1 by 3. You will get this because it will be 2 square will be 4, 4 and 4 will go, and p will be 1 by 3. Question number 12 is, question number 12 says that for what value of the parabola y square is equal to 18x is the ordinate equal to it is 3 times it is abscissa. That means ordinate y is equal to 3x, y is equal to 3x. We have to find what? We have to find the point. We have to find the point where this happens, y is equal to 3x. Now equation of the parabola is given, that is y square is equal to 18x. Let this x is equal to say t. According to the question, y is equal to, according to the question, y is equal to 3 times, that is it is 3t. Since this t comma 3t lies on this first, so it will satisfy it, so we will get 9k square is equal to 18k, which implies k is equal to 2. Therefore, substituting in this, it is, sorry I have took it, this is t, is we will get t as 2. Using in this, we will get y is equal to 6. Therefore, we will get y is equal to 6. Therefore, required point will be this 2 comma 6 will be the required point. And question 13 is, show that the area of the triangle inscribed in the parabola y square is equal to 4 y square minus 4x is equal to 0 is this. That means inscribed in a parabola, we have, this is the parabola and a triangle. Find the area of the triangle which is inscribed. This, let this is a x1 y1, b x2 y2, and c x3 y3. c x3 y3. And question says, show that the area of the triangle inscribed in the parabola y squared minus 4x is equal to 0 is this. Now let these 3 points where these are the vertices of the triangle which lie on the parabola. So since this A lies on, since A x1 y1 lies on y square is equal to 4ax, which implies it will satisfy it, that is y1 square is equal to 4ax1, which implies x1 is equal to y1 square by 4a. Similarly, we will get x2 is equal to y2 square by 4a and x3 is equal to y3 square by 4a. Now what we have to show? We have to show the area inscribed. So we therefore the vertices of the triangle are, it is x1 y1 square by 4a comma y1. Similarly, the other two vertices, that is y2 square by 4a comma y2, y3 square by 4a comma, that is y3. These are the three vertices of the triangle. Now we know that area of the triangle, therefore area of the triangle, it is 1 by 2. This is x1 y1, x2 y2, x3 y3, and we write it is x1 y1 1, x2 y2 1, x3 y3 1, 1 by 2 times, and it is 1 by 2, it is y1 square by 4a, y2 square by 4a, y3 square by 4a, y1 y2 y3 1 1 1, and that will be, let's take this 4a out, it will become 1 by 8a, and it will be y1 square, y2 square, y3 square, y1 y2 y3 1 1 1. Now if we operating c1 as c1 minus c2, and c2 will get changed to c2 minus c3, if you will operate this, you will get the required area. Now last question is, if xy is a point on the parabola y square is equal, prove that the distance from the locus is x plus a. That is the that is the equation of the directrix. You have to find the equation of the directrix. You try these at your residence. If you will not go through any question, then ask me. Inshallah, I will try my best. Assalamu alaikum.